Hello everyone. Today we are going to start with chapter 2, solving equations and inequalities. We're going to first look at the section 2.1. In section 2.1, we are going to look at linear equations and problem solving. The first thing we need to know is what is an equation. Now, equation is a statement that two algebraic equations are equal. For example, 2x minus 3 equals minus x plus 6. X over 3x squared equals 1 over 3x. Then square root of 2x equals 4. Now these are some of these simple examples. So the next step would be is how would we like to solve them? Now when we say solving an equation, it means what value of x will make the equation true. That is the value of x. So let's look at the first example. We have 2x minus 3 equals minus x plus 6. Now first we're going to solve for x. Here means basically get x's on the left hand side and all the constants on the right hand side of this equal sign. So we have 2x plus x, which gives us 3x, and on the right hand side we get a 9. So the answer to this equation is x equals 3. Now let's look at another equation, which is x over 3x squared equals 1 over 3x. So clearly on the left hand side we can cancel this x, and now we are left with 1 over 3x. Now this is the same as on the right hand side. Okay, now let's look at the third example, which is the radical root function example. Now this one is a square root of 2x equals 4. To solve for x, we are first going to square this equation. Now when you square it, notice the left hand side we can cancel the square root with the 2 and we will be left with 2x. On the right hand side of this equal sign we get a 16. So for this equation, the solution is x equals 4. Now, so we have learned about what is an equation and how do we solve an equation. Let's go ahead and look at types of equations. Now, in types of equations, there are three kinds. Now, they are the identity, conditional, or contradiction. So the first thing we're going to look at is identity. Now, in identity, it simply means that an equation that is true for every real number in the domain of the variable. Now, this was the example we had taken earlier. So clearly, x over 3x squared is equal to 1 over 3x. This is true for every statement, every value of x except 0. Now, let's look at the next one of the type of an equation. This is called the conditional equation. Now, in a conditional equation, it means the equation is true for some values of the x in the domain of the variable. For example, let's look at x squared minus 9 equals 0. Now, this equation is true for only two values of x, 3 and minus 3, but none for any of the other real values. The last type of equation is the contradiction one. Now, the contradiction one is that this equation is false for every real number in the domain of the variable. For example, let's look at this one. 2x plus 1 equals 2x minus 3. Clearly, there is, so even if we cancel this one, so 2x plus 1, so normally what we will see. So let's write this one down. So we have 2x plus 1 equals 2x minus 3. Clearly 2x is the same in both sides of this equal sign. So this whole thing cancels out. What are we left with? We are left with 1 equals 3. Now clearly this is not possible, and hence this equation is a contradictory type of an equation. Let's go ahead and now solve some equations. So we're going to start with the example. We're going to look at 3x over 8 plus 4x over 3 equals 1. Before we can solve this for x, we have to have a common denominator on the left-hand side. So the least common denominator of 8 and 3 is 24. So what we're going to do next is multiply on the left-hand side the number which will make this part of the equation to have 24 on the denominator and this one again to be 24. So what do we see is when we multiply 3x over 8 by 3 and 3 on the numerator and denominator, that what we will get, we are going to get is 9x over 24 plus, now for 4x over 3, we're going to multiply by 8. So what we get is 32x over 24. Now this equals 1. Now moving forward to solve it, now both on the left-hand side of this equal sign, 24 is the common denominator, so we can add the numerators. What do we get? 41x over 24 equals 1. Now to solve for this x, we're going to multiply on both sides of the equal sign by the reciprocal of 41 over 24, which is 24 over 41. Oh, sorry. So what do we get? We get that x equals 24 over 41. Now remember, these ones cancel out. Let me show that. So this 24 with this 24, 41 and 41. Remember, this is a multiplication sign, guys. So the final answer is 24 over 41. Okay, now let's look at another kind of example. This one is given as 4 times y minus 2 plus y equals 9 minus 8y. So here we have to solve for y. Now before we can solve, we have to first distribute this 4 inside this expression y minus 2. So let's start here. What do we see? 4y minus 8 plus y equals 9 minus 8y. Okay, now look at this one. So first we'll gather the like terms. 4y plus y, we get 5y minus 8 equals 9 minus 8y. Now gather all the y's on one side, the constants on the other. What do we get? 5y plus 8y equals 9 plus 8. So solving, we get 13y equals 17. Now we need to get the y with the coefficient 1. So what we're going to do is we're going to multiply by the reciprocal of 13, which is 1 over 13 on both the sides. So we get 1 over 13 here times 1 over 13. So we can cancel out the 13s here. So what do we get the answer to be? Y equals 17 over 13. Okay, so here have we looked at two kind of examples. Now let's look at more of these solving kind of problems. So the first one we're going to look at is an expression where there's a rational expression on the left hand side and also as well as on the right hand side. Now in order to solve this problem, the most easiest way is do cross multiplication. So let's do cross multiplication. So what do we get? We have x minus 2. Now make sure you're keeping your parentheses. Multiply 2 over 4 on the left hand side. This equals 3 times the expression 5x plus 1. Now let's go ahead and now distribute the 4 on the left hand side and distribute the 3 on the right hand side. So on the left hand side, what do we get? 4x minus 8 equals 15x plus 3. So now we get the x's together. Now I prefer to take the x's over here on the right hand side because I will have a positive constant to it. You can even take the 15x over here. It's not going to make a big difference. So let's start take the x's on the right hand side. So we are going to take the x's here. So this will become what? So let me just first show you here. So I'm doing minus 4x here and a minus 4x over here. Okay, let's... Okay, so what do we get here now? We get minus 8 equals 15x minus 4x plus 3. Now let's get the 3 on the left hand side. So we are going to do a minus 3 here, a minus 3 here. What are we getting here is now minus 11 equals, so we can solve for 15x minus 4x, we get is 11x. Now clearly notice that we can now divide by 11 on both the sides. So let's do the division here by 11 here and 11 here. So what do we get? So this cancels out and this cancels out, and what are we seeing is minus 1 equals x. Okay, so that was a cross multiplication kind of solving the problem. Now let's go and look at a different kind of a problem here where we have expressions. So the first thing we're going to look at is this expression 1 over x minus 2 equals 3 over x plus 2 minus 6x over x squared minus 4. Now, before we solve this one, the most important thing is we need to have a common denominator. On the whole, we can do it together for the whole equation. So notice x squared, so we need to look at the least common denominator of x minus 2 and x plus 2, which actually the least common denominator of x minus 2 and x plus 2 is x squared minus 4. Remember, this is like a minus b times a plus b equals a squared minus b squared. So using the difference of squares, guys. Okay, so coming back, so what we found was that the least common denominator of x minus 2 and x plus 2 is x squared minus 4. So what we're basically going to do, we are now going to have the whole equation, which is given over here, to have the common denominator to be x squared minus 4. So let's go ahead and multiply this common denominator. Now for the left hand side, which has x minus 2 in the denominator, we're going to multiply by x plus 2. The numerator as well as the denominator. Now for this expression 3 over x plus 2, we're going to multiply by x minus 2. The numerator and the denominator. Now for this expression, which already has an x squared minus 4, we just leave it, multiply this by 1, but it's just leave it like that. Now let's go ahead and solve it. So what do we get on this left hand side of the equal sign? So what you get here is the numerator is x plus 2 over x squared minus 4. This equals 3 times the expression x minus 2 over x squared minus 4 and minus 6 over x squared minus 4. Now let's go down and solve it further. So clearly in this expression, every element expression in this equation has x squared minus 4 in the denominator. So we can basically multiply this whole equation by x squared minus 4 and what we will see. So if you notice here, so what we can do is we can multiply this whole equation by x squared minus 4. So when we do that, notice everywhere this common part denominator cancels out. What are we left with? So we are left with, so let's just go ahead and write it down, literally everything here. So we have x squared minus 4 times x plus 2 over x squared minus 4. Remember, this is on the left hand side and I'm keeping my parentheses handy. Now once again we multiply this by x squared minus 4, the whole big expression, 3x minus 2. Oh, that's great. X squared minus 4, the minus, then x squared minus 4, this expression 6 over x squared minus 4. Now clearly we can cancel the x squared minus 4's in each of this expression in the equation, and now we are left with x plus 2 equals 3. Now remember, I have not yet opened up this expression, which I'll do it in the next step. I just first wanted to get, rid of this x squared minus 4 in the denominator. Now it's simple. We can open it up and now solve for x. So the first thing we're going to do is left hand side remains as it is of the equal sign. Open up the 3 or distribute the 3 to this expression. 3x minus 6 minus 6. Okay. Let me just check. Oh, I forgot. Sorry guys, I forgot to carry the 6. So let me just write this one down. Yeah, so this was 6x and 6x. And here I was making there was a little mistake, but that's okay. So let's get this 6x, which I had forgotten to carry. So now we are having it right. So let's go ahead and solve this. So we can get the x's on one side. But first, before I get the x's, let's get one common x on the right hand side. This equals minus 3x minus 6 and x plus 2. Now I would like to get the x's on the left hand side, because when I get the 3x over here, I get a positive x value here. So we are now going to add 3 x's here. So what do we get? We get 4x plus 2 equals negative 6. Now get rid of the 2 here. So once again, just subtract the 2. So what are we getting? Is 4x equals negative 8. And clearly the answer for this one is x equals, or you can divide by 4 both sides. Its answer is minus 2. So we can divide by negative 4 on both the sides, and we get the answer to be minus 2. Now let's look at solving when there are variables present, and variables are always there, but we're going to solve for the variables. So let's look at the first problem, which is solve for this capital P in the equation A equals P plus PRT. Now, in order to solve this one, I need to gather the P together on the right hand side. So let's go ahead and do that. So first I'm going to gather P common here. And so when I'm doing this distributive scenario, so I'm going to have 1 plus RT on the right hand side. This equals A. Now to solve for P means the coefficient of P should be 1. We have 1 plus RT. We can divide this whole expression by 1 plus RT. So let's divide this by 1 plus RT. 1 plus RT. So on the left hand side, 1 plus RT cancels out. What do we left with? P. And on the left hand side, the answer is A over 1 plus RT. Now let's look for another kind of example. Okay. Now here we are going to solve for h in this equation given by v equals 1 over 3 pi r square h. Now if you remember from geometry, this is the volume of a right circular cone. Now in order to solve for h, basically means h should be on one side of the equal sign with coefficient 1. Now we have 1 over 3rd pi r square. So what basically we're going to do is we're going to multiply this whole equation by 3, which is the reciprocal of 1/3, and also divided this expression by also pi r squared. So let's write first cancel off the 3, so we can do this by let's write 3 here. Multiply this expression, what do we get? 3v equals 3. I'm going to write this in this 1 over 3 pi r square h. Clearly, this 3 and this 3 cancel out, and then we have 3v equals pi r square h. Now remember, we still have pi r square in front of h. We're going to divide this whole equation by pi r square. So when we do that, notice we can cancel on the right hand side the pi's and the r squares. So our final answer is 3v over pi r square equals h. And that's our answers. So we have basically finished section 2-1, and next we will start with the different kind of problems, which will be basically finding equations graphically. So see you later.